Your car's engine is like its heart. It's the part that gives the car movement by generating power. Think of it like this. Your car needs energy to move, just like you need energy to run. The engine takes fuel, like gasoline, and air from outside, mixes them together. Then it burns this mixture in a special controlled way. This burning creates a small explosion. These small explosions push parts inside the engine, which turn the wheels, and that's how your car moves on the road. This cycle is often called the four-stroke cycle: intake, compression, power, and exhaust. This amazing process happens thousands of times per minute while you're driving. Every modern car has a small but very powerful computer called the Engine Control Unit, or ECU for short. You can think of the ECU as the brain of the engine, responsible for making all the important decisions to run the engine smoothly, powerfully, and efficiently. Its main job is to control the amount of fuel going into the engine and the exact timing of when the spark plugs fire. The ECU works incredibly fast, making hundreds of calculations every second while you're driving your car on the road. It gets information from many different sensors around the engine. These sensors are like the ECU senses. They can feel temperature, measure pressure, and see how fast things are moving. The ECU takes all this information from different sensors and uses it to make the best decisions for the current situation. It's like having a master mechanic under the hood, constantly tuning your engine for you. One of the most important sensors for the ECU is the crankshaft position sensor, or crank sensor for short. This sensor has a very important job. It tells the ECU how fast the engine is spinning. The crank sensor works in a simple but clever way. A special wheel with many teeth, like a gear, is attached to the crankshaft. It's called a reluctor wheel. The crank sensor is a small magnetic pickup that sits very close to these teeth. Every time a tooth passes the sensor, it creates a small electrical signal. The ECU counts these signals to figure out how fast the engine is spinning and the exact rotational position of the crankshaft. This information is so important because spark timing is everything. The ECU needs to fire the spark plug at the exact moment when the piston is reaching the top of its compression stroke. If the spark happens too early or too late, the engine will lose power, waste fuel, and could even be damaged. The crank sensor provides the ECU with the precise timing information it needs to do all this perfectly, thousands of times per minute. Another very important sensor is the Manifold Absolute Pressure Sensor, or MAP sensor. Its job is to measure how much air is going into the engine. An engine needs a specific amount of fuel with the amount of air. This is called the air-fuel ratio, and the MAP sensor helps the ECU figure out the air part of this ratio. It does this by measuring the pressure or vacuum inside the engine's intake manifold, the part that distributes air to all the different cylinders of the engine. When you press the gas pedal, you're actually opening a valve called the throttle body. This lets more air enter the engine, and when more air comes in, the pressure inside the intake manifold changes. The MAP sensor immediately detects this change and sends a new signal to the ECU. The ECU sees this signal and knows you want to accelerate. In response, it tells the fuel injectors to spray more fuel into the engine to match the increased amount of air. This keeps the air-fuel ratio correct and gives you the power you need when you step on the gas. When you're just cruising on the highway, the throttle is mostly closed, creating more vacuum in the intake manifold. The MAP sensor reports this low pressure to the ECU, which reduces the amount of fuel being injected, helping your car save a lot of gas during gentle driving. After the engine burns the air and fuel, it needs to get rid of the leftover gases. These gases exit through the exhaust pipe, but before they leave, they pass by another very important sensor, the oxygen sensor, sometimes called the O2 sensor. The oxygen sensor's job is to check for unburned oxygen in the exhaust gases. This is important because the amount of leftover oxygen in the exhaust tells the ECU whether the air-fuel mixture was correct. If there's too much oxygen, it means the mixture was too lean, too much air, not enough fuel. If there's too little oxygen, it means the mixture was too rich, too much fuel, not enough air. The oxygen sensor acts like a final inspector, checking the results of the combustion process and giving feedback to the ECU. The ECU uses this feedback to make fine adjustments to the air-fuel ratio. This creates a continuous feedback loop. The ECU makes a decision. The O2 sensor checks the result, and the ECU adjusts its decision. This constant checking and adjustment helps keep the engine running as clean and efficient as possible. Most modern cars have at least 2 oxygen sensors. The first is before the catalytic converter and helps the ECU control the fuel mixture. The second is after the catalytic converter and checks that the catalytic converter itself is working properly. Finally, the crank sensor, map sensor, and oxygen sensor all work as a team. The crank sensor sets the timing, the map sensor measures the load, and the O2 sensor checks the final result. This teamwork allows the ECU to control your engine with amazing precision, giving you a car that is powerful, fuel efficient, and environmentally friendly.